Okay, so I need to make a quick video for my students tomorrow, talking about area. So, with the area, first thing we need to know is what figure we have. Obviously, we are looking at a trapezoid because we have these two sides pushing out. The base 1 is different than the base 2. It's not like the same on the top and bottom, like a rectangle or a square where all four sides are the same. We have different lengths on the top and bottom, so that's why we look at it and call it a trapezoid. So if that's the case, we need the area formula, which is 1/2 base 1 plus base 2 times height. And this is the area formula for a trapezoid. So what that means is we need to know what the height is. Well, the height is the number that comes straight up, forms a 90-degree angle, make it a little bit darker, forms a right 90-degree angle and goes straight up. So we know the height of the trapezoid, which is different than these legs. And the legs we talked about in the perimeter, but we don't need the legs at all for this problem. So the height is 6. My base 1, we're going to call that the top, and then my base 2 is going to be the bottom. So that we have base 1 equals 7, base 2 equals 13. And this is given information because the picture tells you. If the picture tells you anything, that's considered given information. So, with that, we need to substitute these numbers in. So for our height, we have a height of 6. So I'm going to change that. For the base 1 is right here. I'm going to change that to a 7. And then we have a base 2, which is 13. So these are the three numbers that need to get plugged in for our variables. So instead of B1, B2, and H, we're going to use 7, 13, and 6. So that when we rewrite it, we're going to have area equals 1/2 7 plus 13 times 6. And this is what we call substitution. Now, at this point, I want you to just talk about what you're doing, whether you want to use combined like terms, whether I want to do simplify the parenthesis. I just need you to start justifying in your own words what you are doing. So I'm going to call this simplify parentheses. So I'm going to simplify what's in parentheses because the order of operations, we definitely need to do parentheses first. Then, but look what happens. If I take half of 20, that's not too bad because half of 20 is 10. So I'm going to multiply. Okay, and then do 10 times 6, and my area equals 60. And we can say multiply again or combine like terms. What I'm looking for is that you just understand you are trying to get to the area of the equation. However that works. Okay. Next, let's move ourselves over. I wonder how I do that. Can I slide myself over? Okay. And then I'm going to put this here. All right, so far so good. Come back here, grab problem number 2. Come back to this and then paste it. Make sure you can see it on the screens. Okay, all right. So this time we need to match up our shape with our shape. Okay. So for this problem, we need the area of the rectangle, which is base times height. And this is the area of a rectangle. Okay. So usually if the box is sitting upright, you would consider this side right here. You consider that the height. But like we said today in class, whether we talk about 2 times 7 or 7 times 2, the answer, either way we get, is going to be the same. Whether you do 2 times 3 or 3 times 2, your answer is going to be the same outcome. So just understand that if you were to label this the base and that the height, it's not going to matter. Okay? So my base equals 7, my height equals 2. We know that because the picture tells us. So that is what we call or consider given information. Okay? Then once we get that, substitution. So we're going to substitute these numbers into our equation. So area equals, and let's highlight what we're doing, B and B, and then H and H. Okay? So we have these two different variables that we are going to change the letters to the actual numbers that they are. So we are going to do 7 times 2. And our area is going to come out to be 14. And how did we do that? We combine like terms, or you could have said multiplication. Not property of equality, because we didn't do it to both sides of the equation, but just multiplication in itself. And that's going to be whatever you're comfortable with. I'm not going to stress too much for myself or my students. If, you can decide what you want to do as you are the student. All right, now can I move this down? There we go. That's what I'm looking for. I need to move it down. There we go. And then I'm going to move this over. Buffalo Bills equals Super Bowl. Hey, quarterback's a little rough right now. Hope he gets it together. All right. Next one. But me being a Lions fan, I know how it goes. Because we've been on the struggle bus for probably since my entire life span. Yeah. I only know this because I have Stefon Diggs on my fantasy team, so otherwise I don't know if I would know. All right. Next one. We have a square. So a square, once again, looking at these pictures, our square right here shows that we have 1, 2, 3, 4 equal sides. That's what those dashes mean on the square. It means that all the sides are equal to each other. So each one of these sides has the same side length. And just like the rectangle where we did base times height, we're actually going to do A times A, which is the side length times the height times the base, whatever you want to call it. But what happens is because they're all the same length, you get this idea of A squared. Okay, so this is the area formula for a square. Okay, so we only need one measure. We need the measure of one side, and then we know all of the measures, because in a square, all the sides are the same. So because we know the one side length is 3, that's given information because the picture tells us. And then we're going to once again do substitution. All right. And then our area is going to be 3 squared. Or you could do 3 times 3. Once again, it's whatever you're comfortable with. And for my students, whatever you want. Either way, I will accept either answer. I don't care. I just want you to be able to get the answer. So when we do 3 squared, or 3 times 3, we get 9. We can say simplify the exponent. That's our justification, and we're good. Like, don't overthink this process, because once we start expanding it to an actual cube where we have to draw the net figure is what they call this. But if you had a 3-dimensional box and you pulled the bottom of the box, okay, let's try and do this with the highlighter. If I pulled the bottom of the box, I would want you to think that this is the bottom of the box. And then we're going to fold out all 4 sides. And when we fold out all 4 sides, this side over here, this side right here, is this side right here, and then the top goes with it, where this top of the box flattens out to here. And this is how you would end up finding the surface area of this entire figure. You would flatten out this box, and then you would find the area of each of these pieces, and then add them all together. Now, because it's a square, all of these areas are actually going to be the same. So we would just take 1, 2, 3, 4, 5, 6 times 9 by 6. And that would be our surface area for this cube that was 3 units in every direction, whether it's base, height, width, all of that good stuff. So this is where my class is eventually going to go to. But I always want to start them with something that they're comfortable with before we go on to the craziness that is surface area. Okay? All right, so let's move this, moving on up to the east side. The deluxe apartment in the sky. Because we're moving on up. All right, so clear that out. Move this over, and we'll pull the circle. Last one, our circle. So then let's go back here. I'm going to post this here, blow it up a little bit so everybody can see it. Okay, so we're doing a circle. So first things first, go back to our formula. Our formula for a circle is pi times radius squared. This is the area of circle. And you could write out circle, or you could draw a circle with the dot in the center. That's another way to represent circle. It's ready to post to TikTok. Okay, thanks. All right. Now, the only value we need is r. And r is what they call the radius. And the radius goes from the center of the circle out to any edge of the circle. And the cool thing about it is, and what I was telling my students today, is when we were finding circumference, if you think about like a piece of string wrapped around it, you cut that string, straighten it out, and then you can find the measure or the length of it for the circumference. So you could literally find the perimeter around the circle by doing that. But for the area, we're looking at painting everything in here. Okay? But if we're going to paint everything in here, the tricky part about that is that you are doing a curved area. So we have to calculate that. And when there's a curve involved, that's when we need to bring pi. Pi is very important to any curved figure. And pi, 5,926, and you could keep going. Pi is a non-repeating decimal that goes on forever. Most people, when you learned about it, were taught 3.14. And that's not too bad of an approximation. And they use these squiggly lines to say that it's not equal to them. It's just approximately what this value is. Okay? So, because it just is a repeating decimal that goes on and on forever and ever. So, when we look at this radius, it's from the center out to any side, and that distance doesn't change as you go around. So this is 6, and we know that because the picture tells us. Now, if they were to give us the whole thing all the way across, that's called a diameter. And when you have a diameter, it's equal to 2 times the radius. So if I wanted the radius, I could take the diameter and divide it by 2. So that is a way to get from diameter to radius and radius to diameter. And for the area formula, you must use the radius. Circumference, there's a trick to that, but for area, you must use the radius. So you've got to take the diameter and cut it in half. Okay, so now go back to our tried and true substitution. All right, area equals pi. And then our R value is going to now become a 6, and then we're going to square it. So then the area equals 36 pi. So we simplify the exponent. Okay. And this is what I would call, for the SAT or ACT, if you're taking this is what I call the mathematical answer. Because in math, a lot of times they do kind of represent things in pi. That's a terrible 3. Let me try and clean that up. So they would say 36 pi. However, when you talk about, I talked in my classroom about track and field. Like, we don't say I'm running the 36 pi meter relay. Like, that's not how it's said. It's the 100-meter relay. So when I get an answer like this, I really kind of need an approximated answer as well. So what I'm going to do is I'm going to take this 36 times it by 3.14 because I want an approximated answer. So when I do 36 times 3.14, I can't do that in my head. I guess why don't we take a quick 3.14 times it by 36. Let's show how we can multiply these two numbers together. So what's going to happen is, first off, ignore the decimal. Just start by doing 6 times 4, which is 28, right? 28, and then 32, and then 36. Okay. 6 times 1 is 6, plus 2 is 8. And then 3 times 6 is, God, I hope it's 18. 12, 18. Yep. Okay. And sometimes instead of doing what's 3, 6, 9, 12, 15, like that way, I do it the other way, where I do 6, then 12, then 18, because it's easier for me to count 3 sets of 6 than it is 6 sets of 3. So that's just kind of how my brain processes it. Doesn't make it right or wrong. I'm just trying to show how it works. Next, we are going to put a 0 here. Because we finished off the 6, we're going to move on over here. And then do 3 times 4, which is 12, carry the 1. 3 times 1, which is 3, plus 1 is 4. And then 3 times 3, which is 9. Okay? Add, and we get 8. We get 10. We get 12, 13, and 10, and then 11. Now, how many numbers are behind the decimal place? We have to make sure and keep those 2 numbers behind the decimal place. And if you think about 3 times 30, that's 90. 3 times 40, which is 120. So we know 3 times 30 is 90. We know 3 times 40 is 120. So our answer better fall in between that category, which 113 does. So I think that as long as I kind of can do some multiplication, that I should be in the right area. And this would be my approximated answer. Okay? Now, I get a